When we see a building, we always think that everyone can access it. But do we really construct our buildings in such a way that every person in the society can access all its services and facilities with dignity and independence? Accessibility to many means just a ramp or at the most a bigger toilet. It is extremely important for everyone to understand that accessibility is not just access to physical infrastructure or facilities. Similarly, access to information and technology is a subject which many stakeholders, service providers, and even DPOs and NGOs are not fully aware of. It is extremely important that public places and built environment must be accessible to all, irrespective of their size, age, and gender. We face a lot of barriers in our surroundings which deter our movement and usage of any service. These barriers are mainly divided into two categories. One is attitudinal barrier and the second one is physical barrier. In addition to the internal and external barriers, there is another barrier which comes in the way of making an environment accessible, and that is our attitudinal barrier. We need to break all attitudinal barriers and stigma attached with the disabled persons to provide an independent, dignified, and mainstream inclusive environment without any social, economical, and cultural barriers. We need to create awareness amongst everyone, including service providers and stakeholders, to promote and provide a user-friendly environment. With people-friendly standards, enforcement is also necessary for making an environment completely barrier-free and accessible for all.
Issue of accessibility is not a rocket science. We just need to consider accessibility in all our internal and external design considerations, workspaces, public areas, and even in transport planning. Every engineer, architect, planner, urban planner, or a road designer, and even the contractors should understand that they have to incorporate universal design in their construction activities.
There are also some other common external barriers like road intersections, curbs and crossings, signals, subways, gratings, open drainages, wicket gate at parks and gardens, high and uneven pavements, and uncovered soffit areas under foot over bridges, staircases and escalators, etc. Open drainages and wide gratings should be properly covered, as these could cause accidental hazards. Pavements should be of low height with curb ramps at both ends. Road intersections and crossings must have tactile tiles and audio signals to guide and orient persons with vision impairments and low vision to cross the roads safely. Soffits should be covered with guardrails or grills to avoid persons with low vision and vision impairment to walk into them accidentally. Bollards are used to prevent the entry of two-wheelers such as bicycles, scooter and bikes. However, usually the width between these bollards is less, which obstructs movement of mobility aid users such as wheelchair users, walker and crutch users. It also poses accidental hazards to pedestrians with vision impairment and persons with low vision. Hence, bollards should be at the waist level with a height of 1000 millimeters and with 900 millimeters space between two bollards to allow the mobility aid users to cross it. An accessible parking lot of minimum 2 car parks should be provided for every 25 car space. It should be located within 30 meters of the entrance and should have access symbol painted on the ground and displayed on the bollard at height of 2200 millimeters. Size of the accessible parking bay should be 3600 millimeter by 5000 millimeters. Nowadays, we find ramps constructed at various public and private buildings, bus stops, road intersections, etc. However, these are not constructed as per the standards and the gradients are too steep. Hence, it not only becomes risky for a wheelchair user or a person with reduced mobility, but they have to use more energy and might need assistance in accessing it. And at some places, ramps are not at all accessible. Many a times, the ramps are constructed with 1:6 or 1:8 gradient. However, the maximum gradient for internal areas should be 1:12 and for external spaces it could be 1:20 or 1:25, provided there is adequate space. If the gradient of the ramp is 1:20, it means for 1 unit of height, the length should be 20 units. In ramps, for every rise of 750 mm, the landing area should be provided, which should not be less than 1500 mm by 1500 mm. Also, for every turn, landing area should be always provided with the adequate space. Accessible design considerations are also applied for steps which, if not constructed as per standards, can be hazardous sometimes. The risers of the stairs should be uniform and edge of the steps should have a contrast color band. Usually, we find handrails on only one side of the stairs. Handrails should be provided on both the sides of the stairs to allow left and right hand users to take support. Handrails' ends should not be open-ended but either rounded off in the wall or grouted in the ground. Handrails should have bars at 2 levels, that is, lower level for children and wheelchair users and the upper handrail for the adult height. For persons with vision impairment, a braille plate or braille sticker should be provided on the handrails to inform them of facilities or amenities ahead of them. A combination of steps and ramp is recommended as persons using bilateral crutches find it convenient to climb steps rather than the ramp. Good examples of steps and ramp combinations are found at Delhi Haat and Garden of 5 Senses in Delhi. Lifts are essential at multi-story buildings where ramps cannot be provided. But just installing the lifts is not the solution. We need to make standardized lifts according to the set guidelines to make these completely accessible by all the users. The size of the lift should not be less than 1400 mm by 1400 mm with door opening of minimum 900 mm. It should have braille buttons, audio announcement system, grab bars, mirror on the front wall and symbol of accessibility, that is, wheelchair logo. Mirrors are used in the lift for wheelchair users as their face is opposite to the door. Hence, they can see the floor numbers in the mirror. Kick plate in the lift protects the lift walls from damage by mobility aid users. The control panel in the lift should be placed at a low height between 900 to 1000 mm so that it can be accessed by a wheelchair user and a short-statured person.